Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Farah Izzati binti Tasid with metric number D2024-1110956. Today, I will present part 5 of operating system, which is memory management. So what is memory management? Memory management is one of the most important functions of an operating system. It is responsible for managing the computer's memory RAM so that multiple programs can run efficiently at the same time. The operating system keeps track of which parts of memory are currently in use and which parts are free. It also allocates memory to applications when needed and releases it after the program finishes. Without memory management, programs could overwrite each other's data, causing errors or system crashes. Memory management is important because it helps the computer use its RAM efficiently. Its main purpose are to allocate memory to running programs, to prevent different programs from interfering with each other, to maximize system performance, and to allow multitasking where several applications can run simultaneously. For example, you can open Microsoft Word, Google Chrome, and Spotify at the same time because the operating system manages memory for each application separately. Next, I will explain about functions of memory management. The first one is memory allocation. Memory management allocates the required amount of memory, RAM, to programs and process when they start running. It ensures that each application receives sufficient memory to execute efficiently without affecting other programs. For example, when you open Microsoft Word, the operating system allocates memory for the applications to load and run. Second, memory deallocation. After a program is closed or no longer needs memory, the operating system releases that memory and makes it available for other applications. This prevents memory from being wasted and improves overall system performance. For example, when you close Google Chrome, the memory it was using is freed for other applications. The third one is memory protection. Memory management protects the memory space of each process so that one program cannot access or modify another program's data without permission. This improves system security and stability. The number 4 is memory tracking. The operating system continuously keeps track of which areas of memory are currently in use and which are free. This helps allocate memory efficiently and avoids conflicts between processes. For example, Windows monitors available RAM to decide whether a new application can be loaded. The last one is virtual memory management. When physical memory RAM becomes full, memory management uses virtual memory by temporarily storing less frequently used data on the hard disk or SSD. This allows more programs to run simultaneously, although performance may be slower than using RAM alone. For example, if you have many applications open at once, the operating system moves inactive data to virtual memory to free up RAM. Next, I will explain the concept of swapping. Swapping is a memory management technique used by the operating system. It temporarily moves an entire process from the main memory or RAM to secondary storage such as a hard disk or SSD when more RAM is needed for other running processes. Once the process is needed again, it is loaded back into RAM. Now let's look at the advantage of swapping. First, it allows more processes to run than the available RAM can normally support. Second, it improves CPU utilization by keeping the processor busy instead of leaving it idle. Finally, it supports multitasking, allowing users to run multiple applications at the same time. However, swapping also has some disadvantages. Since hard disks and SSD are much slower than RAM, accessing swapped data takes more time. If swapping happens too frequently, it can significantly slow down the system. This condition is called thrashing, when the computer spends more time moving data between RAM and storage than actually running programs. For example, suppose your computer has only 8 GB of RAM, but you open a web browser, Microsoft Word, Zoom, and Photoshop simultaneously. If RAM becomes full, the operating system may temporarily move the inactive Word process to disk so Photoshop can use the available memory. When you switch back to Word, it is loaded into RAM again. In conclusions, memory management is essential because it allows the operating system to allocate, monitor, protect, and release memory efficiently. It improves system performance, supports multitasking, protects applications from interfering with each other, and ensures the computer operates smoothly. Without effective memory management, Modern operating systems such as Windows, Linux, and macOS will not be able to run multiple applications reliably. That's all from me. Thank you.